Hello, class, and welcome to Inelastic Collision Notes, which you'll be doing on page 55 of your interactive notebook. Alright, so let's get started. You have your notebook. Just in case you don't remember, this one on the right-hand side will be page 55, and on the left over here will be page 54. This should be blank right now. We're going to take notes over here today, and tomorrow you'll be using this piece of paper, but not today. It should be blank. Moving on. Conservation of momentum. So before we can learn about inelastic collisions, we need to talk about one of those big laws in physics. There are really only a few. Things like Newton's second law, and the first, and the third, and the conservation of momentum, which says that momentum, how much oomph something has, doesn't get to just magically disappear. The total amount of momentum in the world stays constant, always, no matter what. So, how are we going to write that? We're going to say the total momentum before a collision. A collision would be a crash, so when two things bump into each other. The total momentum before a collision must be the same as the total momentum after the collision. Alright, so what does that mean? Well, that means that if we're playing football, Mr. Saslow, football, and here's someone else coming to tackle Mr. Saslow. We'll call this before the collision. However much momentum there is right here, this guy's momentum plus this guy's momentum has to be the same as the total amount of momentum after the crash. There's my football, and there's the guy tackling me. Alright, let's do some labeling. This is guy A, and this is guy B. This is still A, this is still B. What I'm saying is the total momentum before the crash, so the momentum of person A plus the momentum of person B is going to give me the total momentum. What I'm saying is that the momentum of person A initial plus the momentum of person B initial must equal the same total momentum as the momentum of person A final plus the momentum of person B final. Now, this does not mean that person A's momentum does not change. What this means is that the total amount stays the same. For instance, maybe this is, let me think. Let's say this is 8 Newton seconds of momentum, and this guy has 2 Newton seconds of momentum. And then now it's 5 Newton seconds and 5 Newton seconds. Their momentums have changed, but the total amount of momentum has not. That is the conservation of momentum. Alright, next. Today we're learning about the most important kind of collision, at least for us, called inelastic collisions, or sticky collisions. An inelastic collision is when things bump into each other and grab onto each other at the same time. So, we're going to say, when things stick, after they collide. So a really good example of an inelastic collision would be tackling someone. These two people are now stuck together. Another good example would be, let's see, a bow and arrow. When you shoot something into something else and it sticks. Anything involving Velcro or magnets. Car crashes, where the cars get sort of fused together a little bit. All sorts of interesting things. So, inelastic collisions, when two things become one thing. Ooh, that's a good way of saying it. When two things become one thing. So I'm going to redraw this, but a little more simply. So I got thing A, and I got thing B. Here's the velocity of A. Here's the velocity of B. This is before the collision. After the collision, they're two things, sort of, but they're stuck together. So I'm just going to pretend they're one thing. They've become one thing. He's holding on. So they're one mass, as far as we are concerned. If there's only one mass, that means there's really only one velocity. Interesting. What does this mean for our math, Mr. Saslow? Well, this means that the momentum of person A, initially, plus the momentum of person B, initially, has to be equal to the momentum after the crash. Ooh. Alright. Let's break it down a little further. If you remember, momentum is equal to m times v. This means that ma times va initial, the momentum of person A before the crash, plus mb vb initial, the momentum of person B before the crash, has to equal the mass times the velocity, the momentum of the one thing moving after the crash. Alright, so here we have this beautiful equation. So let's say I gave you MA, MB, and I want you to solve for V final. Okay, well that's not too hard. You would, find the momentum of A before, find the momentum of B before, add them up, then you do MA plus MB, and then you'd have answer equals number times VF, solve for VF. All right, let's see what's next up on the agenda. Ooh, an example problem. I love example problems. A 68-kilogram football player is running at negative 5 meters per second when he is tackled by an 85-kilogram player running at negative 8 meters per second. After the tackle, they travel together before hitting the ground. With what velocity do they travel after the collision? All right, so I underlined all the most important parts. Let me read it again. A 68-kilogram football player, that's a mass. Is running at negative 5 meters per second. Oh, okay, well. And this is before the crash. When he is tackled by an 85-kilogram player. Ooh, okay, all right. Running negative 8 meters per second. All right, so this is still before the crash. I means initial, so before the crash. After the tackle, they travel together. They travel together. That is a key phrase right there. If they travel together, or they stick together, or they become one, or meld, or however I say it, that means that I'm dealing with an inelastic collision. All right, before hitting the ground, with what velocity? All right. Oh, well, hey, look at this. This is exactly what we were talking about right here. So all I got to do is rewrite this equation, plug in my numbers, and solve. All right, so let's do that. My equation is MAVAI plus MBVBI equals MA plus MB V final. Let's plug in numbers we know. 68 times negative 5 plus 85 times negative 8 equals 68 plus 85 times V final. I got to solve for V final now. All right, well, maybe you can do this in your head, maybe you can't. In any case, I'm going to use a calculator. 68 times negative 5 gives me negative 340. 85 times negative 8 gives me negative 680. 68 plus 85 gives me 153. Oh, okay, well, this is easy now. Just got to combine these two. Negative 340 plus negative 680 gives me negative 1020 equals 153 times V final. All right, one more step. I need to get V final alone. Well, I need to get rid of this then. So I'm going to divide both sides by 153, telling me that my final velocity is going to be negative 6 dot, I'm going to round it to 67 meters per second. So that means that after the 85 kilogram player tackles the 68 kilogram player, they travel off together at a speed of 6.67 meters per second. Negative. What does the negative thing mean? It means direction. So what direction is negative? It means left. To match your picture. Everything's going to the left. Everything's going in the negative direction. All right, well, that was easy. Not too bad. Now, if you have any questions, go to the Share Stuff section and post those questions. Be as detailed as you can. Mr. Sazo, I don't understand when blah, 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 or what about this? Do not just tell me I don't get it. If you tell me I don't get it, I'll just say, get what? This is not a helpful statement to me. Tell me something specific so I can help. All right, thank you very much. And at this point, you have a lot of work to do on your project, your case file stuff. So if you don't remember how to get to your project briefcase, on Echo, go to Physics, click on Projects, and the name of this project is Accident Reconstruction, Momentum. All right, there you go. Go ahead and get started.